Let's have some fun with finding impossible integrals. Can't wait. Okay, so they're not really impossible, but they're going to look impossible because we don't necessarily have techniques for integrating the expressions inside the integral, the integrand. So we're going to use the fundamental theorem of calculus, our calculators, and a little brain power to solve these problems. Okay, here's our original problem. Let f of x be an antiderivative of x divided by x cubed plus 1. If f of 0 equals 2, find f of 3. Note, we are not being asked to find the antiderivative. We just need to find the value of the expression at x equals 3. Okay, let's try this. From the fundamental theorem of calculus, part 2, the applicable part, we know that the integral from 0 to 3 of x over x cubed plus 1 with respect to x is f of 3 minus f of 0, the antiderivatives. Well, what we need to find in this particular problem is f of 3. We know f of 0 is 2, and we can use our calculator to get a value for this expression. So let's try that. Solving for f of 3 gives me this, and I know f of 0 is 2, so I have the definite integral plus 2. All right, let's pull out the Inspire or the 84 if you still have one. Using numeric integration techniques, I know that the definite integral from 0 to 3 of x over x cubed plus 1 dx is 0.878888889888189. You get the picture. And so if I just add 2 to this value, I have just found the impossible integral. So f of 3 ends up being 2.87888. Anyway, make sure you round to at least 3 decimal places of accuracy. You can round up or down, but make sure you at least have 3 decimal places of accuracy. All right, let's try one more. Let f of x be an antiderivative of 4x squared plus 5. If f of 1 equals 3, find f of 5. Okay, again, I don't have integration techniques for this right now. I can't undo this square root and this square, but I don't need to find the antiderivative. All I need is the numeric value, f of 5. So let's use the fundamental theorem of calculus. Recognize that I can use my calculator to find this numerical integral, and I know this value is 3. So what I have, if I solve for f of 5, is this expression here, where f of 5 equals the definite integral from 1 to 5 plus the original position at 1, f of 1, or the definite integral from 1 to 5 plus 3. So I can use my calculator, and I find that f of 5 is... Okay, so the value of f of 5 is 28.86558477. You get the idea. Just remember to round to at least 3 decimal places of accuracy. That concludes this video on finding impossible integrals. Good luck!